Hello students, welcome back to rdchemistry. In this video, let me briefly explain about half-life and rate constant. So here let me take the concept of first order reactions, half-lives. Basically we have the formula K is equal to 2.303 divided by time interval T, then log of initial concentration R naught divided by R, right? R is the final concentration time interval T, K stands for the rate constant. Similarly, we have the half-life for the first order reaction T half is equal to 0.693 divided by K, right? Remember, half-life in the first order reaction is independent of the concentration terms, no initial concentration, right? So based on this, we have got some formula list. T 50% is to T 75% is to T 87.5%. This is meant for first order reaction, is in the ratio 1:2:3, right? Now this can also be written as a T 50% means half of the reaction. T 75 could be written as a 3/4, okay, and T 87.5% can also be written as a T 7/8, or in terms of 1/2 is nothing but 0.5, so I can also write down 0.5, T 0.5, this would be 0.75 and this would be 0.875. Just you have to remember this, right? So now let's proceed now. We have T 50% is to T 99.9% is in the ratio 1:10. Okay. Also T 50% is to T 90% is also equal to 3:10. Now this is very important for us to proceed for the next few tricks. So T 90% I want to connect to half-life. So remember the number 10/3. Next one, T, I'm not completed. T 99% is equal to 10/3. Again, T 99.9% is equal to 10/3. Okay, let me also write one more. T 99.99% is equal to 10/3. Okay, now everywhere multiply by T half. I'm going to connect to the T half. Okay, so multiply by T half everywhere, here also. Okay, into, we want one number here, okay, to make it equal. See here, 90, how many 9s are there? There is only one 9, so multiply by 1. In the second case 99, how many 9s are there? 9s are 2 in number, so you multiply by 2 here. In 99.9%, how many 9s are there? There are 3 9s, so you multiply by 3. Okay, and the last one, 99.99%, how many 9s are there? 9s are 4 in number, so you multiply by 4. Okay, now if you see carefully, see the ratio T 90%, T 99%, T 99.9% and 99.99% are in the ratio of 1:2:3:4. Okay, that is, this ratio is equal to T 90% is to T 99% is to T 99.9% is to T 99.99% it comes. Okay, now let's see this problem. For a first order reaction, half-life is 18 minutes. Calculate the time required for 99% of the reaction. Okay, So they are given half-life T half is equal to 18 minutes they are given. Remember T99 percentage, you remember the numbers 10 by 3, correct, into T half, correct, into how many nines are there? 2 nines are there, you can multiply by 2, right? So it is a 10 by 3 into half-life is 18 into 2 times. So 3 ones are 3 6 are, so it is a 10 into 6 into 2. So this is equal to 10 into 6 into 2 are 12, so becomes 120 minutes, right? Yeah. Now let us see the unit of rate constant K. In general, the unit of rate constant K is equal to in terms of mole liter inverse to the power 1 minus n and seconds to the power minus 1, where n is nothing but order of the reaction. Order of the reaction, correct? If they give the unit in the question, there is one small trick to find out the order. Order is equal to power of the liter term. Power of the liter term you are going to make is of minus power of the time. Power of time. Okay, power of time. Otherwise, you can also try n is equal to 0, 1, 2, 3. Okay, fine. So, suppose they give k is equal to say 6.7 into 10 to the power minus 4 in terms of mole, liter minus 1, second minus 1. I want to find out the order. Order is equal to power of the liter. Liter is here. How much is it? Minus 1. Minus of power of the time. Power of the time. Time is in terms seconds. So it is a minus 1. So it is equal to minus 1. Minus of minus become plus 1 is equal to 0. So it is order of the reaction is equal to 0. Fine. So we have got say one more question. Suppose they give k is equal to 2.5 into 10 power minus 3 in terms of seconds. So this order is equal to power of the liter is not that 0 minus of power of the times second inverse. So minus 1 they are given is equal to so plus 1. So the order of this reaction is equal to 1. Right? So this is very simple for you. Thank you for watching. Have a nice day.